Okay, 5.3, inequalities in one triangle. One thing that you will notice today, no new vocabulary, all right? But then making sure that you understand that there will be inequalities in triangles. Today we're just doing one triangle, just to give you the grounding of what you need for the follow-on sections. Okay, so here's the definitions. Don't forget that you will have an inequality. You can, if you think about it, solve inequalities like equations, but make sure that you put them back into inequalities when you've finished. All right, and here we've got the properties of inequalities, and you will notice that 3 of them you've used before in ordinary congruence, the transitive property. I said you're going to have that so many times. That's the one that was the law of syllogism, where you've got 3 parts, you can miss out the middle part. Your addition and subtraction. The only new one is the comparison. Okay, so just make sure that you put it the right way around. Okay, so here's where your inequalities start. Remember, this guy here is your exterior angle, and these 2 guys are your remote. Well, you do know that in previous sections those 2 guys equal each other, which is what you've got here by the exterior angle theorem. All right, but you know by definition that angle 1 must be greater than angle 2, and angle 1 must also be greater than angle 3, because angle 2 and 3 added together make angle 1, so angle 1 must be bigger than both of them. Okay, so here's example 1. You've got this diagram of triangle JKL with line KM in it. Never assume that M is the midpoint of JL, or that KM is the bisector of the angle K that's there, but you can work out things, all right? But make sure you've got definitions. For a start, if you look at this triangle here, by eyesight it looks like an equilateral. Never ever assume that unless you've got the notation on your triangle, on your diagram. All right, so let's have a look at from the previous example. What we're after is which angles are less than angle 4. Well, we know from the past experience that angle 4 and 6 are vertical angles, so they are congruent. From the diagram it looks like angle 4 is a right angle, but you can't assume it, so you can take 3 and 5 out because you don't know whether it's a right angle or whether it's bigger. There's nothing to know from the notification of it. But you do know that an exterior angle, which is angle 4, is greater than the 2 remotes. So let's have a look at what we've got now. So we can say the measure of angle 4, okay, must be greater than the measure of angle 1 and the measure of angle 2. Okay, that's the only thing that you can conclude from this diagram. Okay, so let's have a look at angle side inequalities. Irrespective of whether it's a right triangle or not, you know that you've always got a longer side. You can't really call it the hypotenuse, but that's a right angle triangle, but you know you'll have a longer side, and that side must be greater than the other 2 sides. Not added together, but the other 2 sides. So you're using sides in exactly the same way as we used angles a few minutes ago. Okay, example 2, listing angles. Okay, we've got this diagram here. PR, well, triangle PQ and R, you know that PR is the smallest side, which is 7.5, PQ 8.8, and finally QR is 9.1. And unless you're told otherwise, always do the smallest to the largest. Okay, so here we go with example 3. You're told that angle G is 45, angle H is 56, and to find F you need the angle sum theorem, which will give you 79 degrees. And again, put them in order from the smallest to the biggest, so that's G, H and F. And you know from previous exercises that the smallest side will be opposite the smallest angle, so that's why you've got FH as the smallest side. The middle angle is H, so that must be the middle side, so FG must be the middle, And then finally, by default, if F is the biggest angle, then the opposite side must be the biggest side, GH. Okay, so let's have a look at question number 5. Putting them in order, BC. Line BC, 1.7. 2.8 is AB. Put them in order now. Third one, 3.1 AC. So there's the angles. Okay, and don't forget the smallest side is opposite the smallest angle. Well, here's the smallest side, that must be opposite the smallest angle, so angle A must be the smallest. Middle size 2.8 must be opposite the middle angle, so angle C. Biggest side 3.1 must be opposite the biggest angle, so angle B. And there's all you need to do as far as putting the sides and the angles in order.